So we'll go ahead and get started. Welcome everyone to our 8th session of the 2022 to 2023 Forest and Climate Learning Exchange Series. I'm your host, Tony Mazza, and I'm the Manager of Policy and Research at the Society of American Foresters. So the Society of American Foresters, also known as SAF, is the national scientific and educational organization representing forestry and related natural resource professionals across the US. We were founded in 1900, and SAF promotes science-based sustainable management and stewardship of the nation's public and private forests. I also want to give a quick thanks to our co-host, Michigan State University's Forest Carbon and Climate Program, or FCCP. FCCP connects diverse forest stakeholders and the broader public with the value of forested lands and forest products in addressing climate change through courses, videos, workshops, and other knowledge transfer materials, as well as policy relevant research on forest carbon and harvested wood products. I'd also like to quickly thank our additional sponsors, NCX and Renew West. So for today's presentation, we'll be hearing from Tony D'Amato, who is Professor and Forestry Program Director at the University of Vermont. The title of his discussion today is Looking at Forest Carbon from Multiple Dimensions, Evaluating Trade-offs and Opportunities to Forest Carbon Management. So big thanks to Tony for joining us today for this very, very timely discussion. Before we get started, we'll do a little bit of housekeeping. So to automatically receive registration details and information regarding upcoming webinars, please join our mailing list by emailing forestc@msu.edu. A recording of this session, along with a copy of the slides and any supplemental resources, will be posted to the FCC website very shortly. Additionally, the presentations today will be followed by a 15-minute Q&A. You can use the chat function or the Q&A function at the bottom of the Zoom interface to submit your questions at any point during the presentation. We're going to do our best to address as many questions as possible, but it may be limited. You can also send questions directly to forestc@msu.edu during the presentation. Attendees today are qualified to receive CFE credits from SAF. The credits will be automatically applied if you register for the event with the email associated with your SAF account. Similarly, attendees are qualified to receive CEU credits from ISA. For CEU credits from ISA, please email forestc@msu.edu with your name and your ISA certification number within 7 days of the webinar. And with that, I'm going to hand it over to the other Tony, Tony D'Amato.
Thanks, Tony, and thanks everyone for logging in today. So let me just get my slide up. Okay, looks like it's coming through. So as Tony mentioned, really what I'm hoping to do today is just talk through some of the different dimensions of forest carbon through the lens of multiple objectives. And as many of you appreciate right now, and really over the past several years, forest carbon has become such a primary emphasis for a lot of the discussions around how forest land should be conserved, how it should be managed. In some cases, often viewed as the sole objective that many want to maximize in a given area. So what I'm hoping to do today is really kind of talk a bit through just what some of those opportunities are for managing for forest carbon. I'll certainly touch upon some of those elements that many of you are familiar with, but really focus more in on just, if we're focusing a lot on forest carbon, what might be some of the trade-offs with other objectives and other values that we also want from forests going into the future. And so to start, I think it's just worth reflecting a little bit on the fact that forests are incredibly complex, and as a result, they give us so many gifts ecologically, spiritually, aesthetically, socially, and so when we look at a given forest stand, a given forest landscape, a given region that's forested, many of us have various values and outcomes from those ecosystems or various species that rely on various features of those ecosystems that we're trying to balance and meet a whole range of objectives that's pretty unique relative to any other ecosystem that's managed around the globe. And so we're going to emphasize carbon a lot today, but a lot of that lens really is to underscore that it's really problematic if we're only focusing on one attribute of an ecosystem that has so many gifts and so many complex elements that we're trying to sustain into the future. And so how do we actually meet some balance and find a way to satisfy multiple objectives, whether they're cultural, ecological, or economic? So those that have been around me a little bit know or are probably suspicious that I have a copy of the 7th edition of the Smith silviculture textbook next to my bed. Don't worry, it's not a true rumor, but I do always like looking at that edition because it's very philosophical and just has a lot of great quotes that are profound given some of the things we deal with today. And so I figured I'd start with this quote from Smith as kind of just a point of important reflection that in 1962, he and of course legislation in 1960 with the Multiple Use Sustained Yield Act was basically pointing out that, the ability to achieve harmony among the major objectives that are sought from managing forests really is challenging. And so as we kind of work through and think about public forests, private forests, family forests, tribal lands, and how this should be stewarded and what the value should be from them, we're trying to find some sense of harmony across these different objectives, which means that kind of putting one objective above all others is going to result in some key trade-offs that we need to consider. And so just like in 1962, today, we know that we can't satisfy every objective in every stand across the landscape. And so how do we achieve that balance, both by acknowledging where trade-offs exist, but also thinking a little bit about how do we have a diversity of conditions across the region and across the country to satisfy all the things that we're looking for from forest ecosystems. So as much as I want it to be about many objectives, there's a good reason why forest carbon is the objective that many are focused on when it relates to forests. And as much as when we think about the debates and some of the challenges that have come with carbon becoming kind of elevated importance in the eyes of the public around forests, the flip side is that people broadly are just recognizing all the amazing things forests do, carbon storage and sequestration just being one of those many factors. But when it comes to talking about future policy, incentives for forest management, forest carbon really does race to the top of most lists. And there's a good reason for that, given just the urgency of the climate crisis we're facing today. We're seeing it daily as it manifests itself in ways that we weren't even predicting 10 years ago. And importantly, people recognizing just how important forests are as a natural climate solution to address and hopefully mitigate some of those impacts. And so on the left, I have a kind of cartoon summary of the work that Griscom did looking at different natural climate solutions. And this isn't up to say that this is the perfect ranking or that all of us have to agree with kind of which is best across the list. The main thing I'm showing that is that if you look through the top 10, forest-related things are the top 3 things best for mitigating carbon and by a long shot. And so when we're talking about forests and we're talking about what should be done with them, it's clear that above so many other ecosystems, above so many other potential land use practices, forests really are such a key area of focus and key area of importance for sustaining those values. Another way to look at the interest in forest carbon is to evaluate just how much it's being researched in the scientific community. And so what I've done on the left-hand side is just show the number of publications back to 1990 that have been published on forest carbon, and I restricted the search to kind of the forestry, what they call meso-level within Web of Science. So just those journals that might intersect with forestry and forestry topics. And so if you're one of the brave souls in 1990, that was one of the 40 people that published a paper on forest carbon, it definitely looked like a visionary today. But you can see pretty clearly just this exponential growth in the amount of science being produced on forest carbon, where we now had over 6,000 papers published on forest carbon in the year 2020 alone. So it speaks to really this increasing knowledge base that we can draw from, both to evaluate what may or may not be the best strategy for carbon from forests, but also kind of the nuance that gets created by more investigation that sometimes is used for different purposes to motivate policy or motivate decisions. In the last 5 years, there's been a tremendous amount of public interest in forest carbon, particularly as it relates to the value of forests as carbon reservoirs, and as a result, why we should not be cutting those forests for other values. And so even though there's a lot of science being created on the nuance and the dynamics around forest carbon, we're seeing a fairly large singular debate around not harvesting trees in the name of forest carbon across all geographies and certainly across a range of different contexts. And so we aren't just gaining a lot of knowledge. Forest carbon is certainly becoming the #1 priority, both within the public, but also trickling into policy decisions, and as many of you are well aware of, influencing markets and other things that we can be involved with. So what I'm going to do for the rest of the presentation is just talk a little bit about those trade-offs and opportunities with carbon, and really kind of use that intro as the backdrop. That we're in a time where a large part of the public, certainly many policy incentives, certainly many aspects of offset markets, are incentivizing kind of high levels of carbon, and in many cases that runs counter to doing active management in a given area. And so much of what I'll discuss are kind of some of those strategies that do require some level of active management, but how those might still be important kind of co-benefits and things to consider when we're balancing, should we be going all carbon here, or should we be thinking about some of the other long-term values, including ecosystem resilience, cultural values, and ecological processes. But to start, I think it's worth just talking about what we're trading off against. And so what are the conditions that really are being kind of incentivized, prioritized, that are often being either paid for or being mandated from a policy or a public perspective, and kind of talk through what that looks like as kind of the contrast as we go through and get into where some trade-offs might exist if that's all we were to manage for or not manage for across this country. So what we're really focused on, and what a lot of the conversation is that climate changing, CO2 is increasing, and so the idea is we want to kind of keep as much carbon that's already stored out of the atmosphere, and as a result, we want to maximize carbon storage. And again, hopefully all of you are very comfortable and well-versed in these general dynamics. But what I've done is in a cartoon form on the left is just a summary of kind of how the amount of carbon in the forest changes over time, as well as how some other things like the rate of carbon sequestration and the general species composition might change. And this is certainly based on the forests I mostly work in the Northeast. One comment about this is that 6,000 papers published in 2021, the 5,000 in 2020, and so forth and so on, there's a wealth of scientific knowledge that really allows us to come up with some pretty strong conclusions that this is the general trend we see the world over. So when we're looking at this, it's just worth knowing there's a lot of science behind this cartoon. So most of you appreciate that, as forests age, they're accumulating biomass. And so generally, older forests have kind of higher levels of carbon storage. And that's a universal pattern I'll talk a bit about a little bit more. The flip side, as forests are aging, and as we kind of get to canopy closure, we start seeing the highest levels of stand level sequestration, even though forests still continue to sequester carbon as they get older, that declines. But much of the discussion around carbon policy and even around kind of payment for carbon is about carbon storage, really trying to give credit for lots of carbon, as well as trying to protect lots of carbon already out there. So it really is about carbon storage that we'll be talking about today. So think about what provides the highest amount of carbon storage. It's worth just summarizing what forests look like that are providing these values as a contrast for what we'll get into. And so these are some generalities. Certainly there's some exceptions, but generally when we look at what conditions correlate well with high amount of carbon storage in the ground, one is high overall live tree stocking. So this graph on the right is just showing above ground biomass versus basal area. As the stocking of that stand goes up, the amount of biomass in that forest goes up. And so just kind of this general overall relationship, more trees, more biomass, et cetera. Importantly, large trees have a really big impact on the amount of carbon that's out there. And so it's not just a lot of trees, but also if we have a high large tree stocking, that certainly can really push stocking carbon levels up tremendously, just given the amount of biomass any given large tree can contain. And then likewise, partly why those stands gain carbon as they get older. It's not just that we're getting more and more big trees, we're also accumulating dead wood, soil organic material. And so we often associate these forests with abundant dead wood. And then finally, those forests that have high carbon storage also often have high structural complexity. And the reason for that is that when we look at an old growth ecosystem, we have species in individual trees of all different sizes that really pack in a lot of biomass into those ecosystems. And so having a diversity of tree sizes, diversity of tree ages, kind of all intermingled in one can create often higher carbon conditions than we might find in a forest that has lower structural complexity. So putting that all together and thinking a little bit about forest development, generally, as I said, what we see as forests age, we generally are increasing in live tree carbon. Other things like biomass and dead wood pools, et cetera, are also increasing and creating those conditions. So those that know what I work on, I'm a big proponent, for old forests and managing for old forest conditions. And we need, lots of areas of high carbon storage. And so it's worth just pointing out just the value of these areas that are either preserved in this form or managed to encourage this form before we get into like contrasting a bit with if this is all we do, kind of what that might mean. And so if you're interested in species, whether for kind of diversity perspectives or for cultural perspectives that are associated with older forest conditions, these high carbon storage forests tend to be really important for providing what those species are looking for. Likewise, in terms of water filtration and storage, those multi-layered canopies often provide kind of that interception and kind of buffering from extreme events. Likewise, deeply shaded forest provides some element of thermal buffering when we have hot weather events, and vice versa. During the winter, can create some unique dynamics with snowpack and microclimate. And then certain species that rely on interior forest conditions that aren't able to disperse very far. These are very important environments. And then finally, I'll talk a lot about kind of resilience of carbon. And in old growth forests, where we truly have old growth, complex ecosystems with a diversity of species, a diversity of ages, kind of multiple structures, that complexity does provide some opportunities for recovery and development, following disturbance. And so even though we think oftentimes that some of these dense stands can be more vulnerable, and I'll talk about that a bit, these complex old forests do provide some adaptation pathways that can be very important. And so even though I'm going to be talking trade-offs, it's just worth getting it out there that these high carbon conditions are super important, but we just need to recognize that this list of bullet points might not satisfy every objective that we have. The other piece that I think is important from a public discourse and policy perspective now is that there is a notion that just because an area has high carbon, that it must be this amazingly complex old forest. And so I think it's just worth pointing out, particularly now as we've introduced this new, and at least from my perspective, highly confusing from an ecological standpoint, term called mature forest, that just because a forest, 75 or 85 years old, like these two pictures here, they have, a good amount of carbon in them. These are high carbon conditions, but they are anything but ecologically mature and ecologically complex. And so as we get into discussing, the value of conserving ecologically mature and certainly true old growth forests, we want to make sure that we're not conflating high carbon stocks with high complexity. Oftentimes you can have high carbon stocks with very simple forests that are anything but the old growth ecosystems that many of us care about. And so making sure that we're keeping that dialogue clear and not conflating the two for political means. So what I'm going to go through for the rest of the presentation is just kind of some examples of trade-offs with that high carbon stocking condition. Again, largely choosing that as the contrast, given that's what we're seeing as being argued for over large areas, primarily through passive management. And so understanding kind of what's the trade-off with if we were to set aside just tremendous acreages for no management in the name of high carbon stocks, what does that mean in terms of other objectives that we might not be satisfying? And so I'll start focusing on biodiversity and then transition into really talking quite a bit about the resilience of those carbon stocks and what kind of a high carbon stock condition means or does not mean in terms of the ability to adapt to change. So to start things off, first want to give credit to Caitlin Littlefield, who certainly has been very influential in kind of advancing some of the ideas around these trade-offs and how to rectify them. And a couple of years ago now, she led a synthesis that really both interviewed different wildlife biologists and managers and also reviewed the literature and looked at, where are there some potential tension points as it relates to sustaining the habitat needs of forest-dependent species that don't really rely on habitats that align well with high amounts of carbon. And so what she did for this work is really look at 4 important ecosystems in the Northeast US and Lake States region that really, support species that are either greatly declining. So a good example being chestnut-sided warblers, or species that are endangered, like certain species associated with pine barrens, certain species, Karna blue butterfly associated with oak savannas, and just evaluated if we were to go from the current kind of high density, kind of second growth forests, often resulting from either agricultural abandonment or becoming denser because of the exclusion of fire and indigenous burning, what would happen if we were to then shift those back to the habitats that these species need? And so it's not rocket science, but it's a challenging narrative if we're thinking about carbon being our overall number one objective. And so as an example, if I'm interested in early successional species, whether it's chestnut-sided warblers or mourning warblers or other species, if I were to go from a mature northern hardwood forest and create this early successional habitat, I've obviously increased the habitat for that species, but I'm also immediately decreasing stand level storage. And so if the goal is maximum storage, I can't pass go in that stand. At the same token, by creating that patch, as all of us recognize, it's not just used by those early successional species. Many of our interior bird species, their fledglings will use that for foraging. And so it's increasing kind of our diversity at the landscape scale, and also getting into kind of some of the concepts of resilience I'll talk about, where by having a diversity of age classes and composition, we're both kind of reducing kind of landscape scale wide loss of carbon, while also creating a unique pathway for recovery in that ecosystem. And so for each of these, whether it's elk, cardinal blue butterflies, buck moths, there's a clear trade-off with providing the habitat for that focal species and providing kind of maximum carbon storage. And so there's certainly some incongruity there, that harmony that was talked about by Smith. It's hard to rectify between those two. And so we should be thinking, are there places where carbon might not be the number one objective, but our ethical obligation to sustain these species should be. What I want to focus a lot on, though, is just what we're doing today when it comes to addressing the climate crisis at one point in time in a very static mindset for an ecosystem that's actually quite dynamic. And so the conditions we see today certainly aren't going to be the conditions we see tomorrow in that forest. And in some cases, what we see today actually can influence how that forest might change and the level of vulnerability of those carbon benefits going forward. And so I'm going to talk a bit about just kind of overall tree stocking, density of trees in the forest, because oftentimes we're using biomass and basal area and other indices as a way to kind of quantify what's the level of carbon stock in an area, and should that area be kind of protected, enrolled in markets, kind of set aside to sustain those benefits. So what you're looking here on the left is some work that Aaron Weiskittel and Chris Woodall did that took all the FIA data across the US and then summarized at that FIA hexagon level the average relative density. So this is kind of the density of that forest relative to kind of the maximum possible. So it's a really good way to see like how much space is there in that forest for growth. If that space gets really occupied, we start seeing high levels of mortality, which we don't want to be seeing, certainly in our ecosystems that we're trying to have resilient carbon stocks in. And so what they did is look at this and kind of categorize things. So this value here on the left, once you get to a relative density of about 0.3, that's when canopies are closing. And so as we start getting above that relative density is when we start seeing some level of self-thinning mortality. And then ultimately, once we get above a relative density of 0.6, where my cursor is, we see extremely high levels of self-thinning mortality. And so trees are dying for various reasons. It can be competition, it can be insect-induced mortality, it can be drought-induced mortality, it can be wildfire, various reasons. But what they found is that this high density condition has increased fourfold over the past 20 years across the US. And you can see that distribution on this map. You also notice some blue areas that are low density, which really correspond with some of our larger fires, as well as some areas where where we might characterize those forests more as woodlands. And so from a carbon standpoint, those high stocking conditions as a snapshot in time actually are going to be rewarded. But if we're already seeing high levels of mortality in these stands, are these the most resilient stocks going forward? And I think that's a key thing that we need to consider when we're talking about, how we're prioritizing certain stand conditions and the key trade-off. So to take that a step further, I think it's just worth digging a little bit into how some of the carbon markets incentivize the level of tree stocking out in the landscape, and might be actually in some cases encouraging stand conditions that are more vulnerable to carbon loss due to mortality. And so what we did is take all of those data across the US and categorize the plots based on a couple of different things. And so the graph on the left is just showing you on the y-axis just 4 different kind of broad classifications. So softwoods on low productivity sites, softwoods on high productivity sites, hardwoods on low, and hardwoods on high. And then what we did for all those plots is on the left-hand side, actually categorize those plots that would qualify today for enrollment in carbon offsets based on the carbon market baseline standards that CARB uses. So kind of based on the basal area in those forests. So the bluish green are those that don't have enough basal area or stocking to qualify. The orange are the ones that actually would be able to enroll. These are the conditions that actually are being incentivized by those markets. And the x-axis is how much mortality, kind of carbon loss to mortality, is occurring. And you can see pretty clearly that those high stocking stands, even though they're kind of meeting that carbon baseline, also are having the highest levels of carbon loss due to mortality. So they might be kind of incentivizing a high stocking condition that might not be resilient. On the right side, we took the same data, and instead of using carbon baseline standard, use it based on like a minimum basal area a forest has to have, we instead use general stocking guidelines for management. Kind of what is the optimal density for managing forests to ensure they have enough space to grow and minimize mortality. And so what you see is that those that are based on that standard have much lower kind of mortality rates, certainly than anything that's enrolled in the carbon markets, as well as anything that's not kind of qualifying for that management standard. So just pointing out that we're often trading off this kind of immediate carbon benefit for kind of long-term resilience of those stocks. So what I'm going to do is go through a few examples highlighting some opportunities or ways to think through, maybe we can't maximize carbon stocks everywhere, but should we instead be thinking about trying to maximize the resilience of those stocks such that we might have to reduce them a little bit to restore certain processes, reduce vulnerability, but does that kind of keep more carbon out of the atmosphere over the long run? So the first scenario I'll talk about is we recognize that there are some vulnerabilities in high density forests to various stressors. And so one of those stressors is drought. So higher density stands been shown often much higher level of mortality and growth reductions during drought. And so if our goal again is to have resilient carbon into the future, then we want to make sure that we are reducing the impact of future droughts as those are certainly increasing across our country and across the globe. So the work you're looking at here just examined different forests that were grown at various densities and looked at historic droughts. So in this case, we're looking at a drought in 2002 and evaluated, depending on how dense that forest is, so this is a measure of the relative density of that forest on the x-axis, what was the level of impact of that drought? And so you can see pretty clearly that lower density stands had more resistance to that drought than higher density stands. But if we look at it through the carbon lens, obviously, if I walked out into that forest in 2001 and wasn't thinking about drought, a high carbon stock condition would have been the one I would say that's the ideal condition from this point in time stocking. Whereas obviously the lower carbon stock condition is the one conferring that higher resilience and greater stability of that carbon. So trading those off is certainly a key issue. Likewise, as I mentioned in relation to different wildlife species, the elimination of fire from our landscape, certainly is a huge issue, particularly in the Western U.S., but really, in any of our woodland and barren communities throughout the country. And so one of the challenges is that, in the absence of fire, these forests densify. And there's been a lot of work showing kind of how dense once open forests have become around the country. And so the challenge is that from a carbon standpoint, again, looking at a forest where fire has been excluded, so we'll take this lower picture here. Although most of us may not view this as kind of ecologically appropriate based on the dynamics of that ecosystem, that from a carbon stocking standpoint has a heck of a lot more carbon in it than this one above. And so some work that's been done looking at kind of this initial trade-off with carbon storage with long-term benefit has shown really nicely that by restoring fire, by thinning these ecosystems, even though that might reduce carbon stocks in the near term, as many of us appreciate, it creates a condition in the long term that when wildfire occurs, actually can burn through that landscape and have much less impact on that carbon we're trying to keep out of the atmosphere than one in which no management is allowed, and then ultimately that burns and has greater impact. And so on the left-hand side, we're looking at some work from Matt Hurdo examining different scenarios. And so he examined areas that didn't have any treatment, areas that were only thinned, areas that were thinned and burned, and then did those under two different likelihoods of wildfire, 1% and 2% annually. And so early on, if you look at those forests that were thinned and burned, of course, the carbon, this is total ecosystem carbon on the y-axis, it goes down. But over time, that carbon recovers. And what you'll see by the end, as wildfire is affecting that landscape, the longest term carbon benefit actually comes from those ecosystems where fire is restored and those ecosystems are thinned. And so even though initially it might be concerning to see carbon stocks reduced, the long-term benefit is much greater than doing nothing in those ecosystems. Again, recognizing that we're dealing with a dynamic ecosystem, that rewarding carbon stocks today without thinking about vulnerabilities could create a challenge. The last kind of example we'll have in that realm is that besides density being an issue from a drought perspective, and certainly being an issue from a wildfire perspective, high density conditions certainly can also present challenges as it relates to insects and diseases and their impacts on host vigor and other factors. And so in the Northeast, those that are logging in from this region, or those just aware of what's going on in the Northeast, there's been an unprecedented range expansion of southern pine beetle up into southern New England at this point. And actually this map is optimistic because this is from 2015, 2016. They've now found this up in Maine. So it's expanded to regions that really actually they weren't even forecasting to have this insect for another 20 years or so. So it's been this rapid expansion, and it's causing widespread mortality of pitch pine, which is a very culturally and ecologically significant tree and an ecosystem. And so we've been looking at these areas where pitch pine's been getting killed by this pine beetle and trying to understand what are the factors that influence the hazard that might predispose one stand versus another of losing this carbon, right? This kind of mass loss of live tree carbon from the site. And so some work that Elizabeth Jameson did developed these hazard rating models based on various conditions that were influencing what she was observing in terms of where southern pine beetle was actually having impact and killing pitch pine. So these two figures are just hazard models that on the y-axis, basically the function is how close are you to a southern pine beetle outbreak, and the x-axis is what the density of that forest is, and then depending on your soils, there's kind of different levels of hazard. And so pretty clearly, not to keep pounding on the lower density theme, but when we look at the low hazards, so these areas kind of in the dark green to moderate shaded green, these are certainly stand conditions that have lower carbon than other forests in the landscape, but actually are consistent with some of the density targets that people use for barren restoration. And so kind of trading off both that restoration objective, that carbon objective, and really factoring in kind of how this also affects the resilience of these ecosystems into the future. And so creating conditions like this, which again, aren't prime carbon, but are resilient carbon into the future. So beyond that current condition and how we might influence that, when we talk about adaptation, and again, those that have spent time either working on the climate change response framework, the adaptation workbook, or have just thought a bit about how do we manage for adaptation, many of the strategies when we discuss creating options, creating multiple pathways for recovery, multiple pathways for adaptive capacity to develop, revolve around taking forests that have largely been simplified by our management or kind of agricultural abandonment or whatever the past land use is in a given area, and using active management to restore structural and compositional complexity. And so in its own right, that approach creates this trade-off where if we want to create some of these complex conditions, we actually have to do some active management to do that, and so reduce those carbon stocks. Likewise, when you look at projections of future tree species distributions and which species are going to be better adapted over time based on climate envelope models and other sources, on average, for most regions, and I'm using the Northeast as an example here in the middle, most of the species that are projected to do better under future climate change are intermediate to sometimes intolerant of shade. So really species we associate with large gaps. And so whether it's natural regeneration, planting, combination of both, if we're really trying to increase the representation of these future adapted species, we need areas that don't have high carbon stocks at local scales, right? Creating gaps, creating openings, because many of these species aren't just going to migrate in general, but also if they were to migrate, going through closed canopy forests is not exactly the niche and mechanism these species use. And so thinking through that key trade-off with adaptive capacity. So just to highlight that with some pictures here, this is in Northern Hardwood Forest as part of the New England Adaptive Silviculture for Climate Change experiment. So we have a gradient going from no management to doing management for resistance, management for resilience, and then management to transition for change. And then you're looking at 2.5 acre stem map plots, and you can kind of see like these are all trees that are 4 inches and above in their locations. So pretty clearly, this gets the gold medal for carbon storage, right? Most mature trees on it. but certainly has the most trade-offs when it comes to adaptation, because the resistance plots, lower density, likely greater resistance to drought and other factors. Resilience plots, these include kind of regeneration openings, so opportunities for new species, and likewise transition, still mature trees in places, but definitely lowest carbon storage you're looking at, but creating these opportunities for other species to possibly on that site, as well as certainly new cohorts to start sucking carbon and being part of that balance between carbon and sequestration at the stand scale. So beyond those adaptation objectives, it's worth just talking a little bit briefly about kind of other ecological and cultural considerations that we might be trading off if we are taking this approach where we want to maximize high carbon on a landscape, and that includes us not doing any management in those areas. And so I think what's a bit ironic is that there's been this push again to kind of create, make 75 to 90-year-old forests kind of this magical criteria of ecological complexity, across a lot of lands in the U.S. But that's often a forest condition that many of us look at and say, wow, that's really simplified. It'd be great if we could do things to increase the complexity. And in particular, it'd be great if we could do things to actually restore and accelerate those complex old conditions that many people are arguing for through protecting mature forests. And so this is just based on northern hardwood forest dynamics, a couple of diagrams showing, if we were to start where many of our forests are in the region I work in, and decide that passively, so with no management, I just want this forest over time to develop old growth conditions. Via natural dynamics and those processes, if we look at kind of average kind of large tree structural conditions in old growth, by about age 200, we'd start kind of achieving some of those and continuing to have old growth conditions. And so if we're okay with kind of allowing that to occur, having very little leverage over other aspects of the ecosystem, then that's one pathway. On the flip side, if I'm all right with maybe allowing for some reductions in the carbon stocking, but actually some thoughtful kind of ecological forestry focused on old growth restoration, that timeline can actually be shortened. And so the irony is, again, that we're being told that we want more ecologically mature old forests in the landscape, but in some cases, we're taking away some key tools that could actually accelerate that via active management. So it's a key trade-off to consider. And again, just to prove that via data, this is with some red pine forests in Minnesota, looking at different densities. So think of this going from low carbon to high carbon, but we're going from 30 square feet of basal area to 150 square feet of basal area. So this forest over time has been maintained at different densities. And what we're looking at here is the density of large trees over time in that ecosystem. So again, most of Forestry 101, lower density stands develop larger diameter trees faster. And so those lowest density stands, basically ranging from 30 to 90 square feet of basal area, really developed kind of fairly high densities of large kind of ecologically mature trees over that time period. Whereas the stands that are going to get the gold medal for carbon storage actually have yet to develop any trees that we would consider kind of ecologically mature trees based on our understanding of old forests. The flip side is the live carbon in that dense stand is fantastic, but we need to think of what trade-off and what are we most interested in going forward. The final comment as it relates to ecosystem values is that many of the woodlands that have densified and really around the country, historically, those barrens and open conditions were maintained by indigenous burning and cultural practices. And so when we think about the challenges or some of the pushback against thinning forests and then introducing fire and doing other processes to restore these, we're often ignoring just the intent and the maintenance of those open conditions is satisfying so much more than biodiversity objectives for the sake of compliance with the Endangered Species Act. And in particular, there's been some great work on the Karuk tribes in California by Long and others that really, through cultural oral traditions and other narratives, pieces together just the value and importance of kind of restoring these more open conditions, restoring cultural burning, both to importantly teach us lessons on ways to impart and develop resilience in these ecosystems into the future, but also to conserve biocultural diversity as well as many other values from these ecosystems. And so again, this is clearly a trade-off with the amount of carbon that's out there, but I would argue that all these values supersede anything to deal with kind of the max stocking on these sites. The last trade-off I'll mention that I think is worth pointing out before we get to kind of what could be a possible strategy is this this notion that we're calling the illusion of proforestation. And I chose that term largely to build off of a paper that was published in 2001 by the Harvard Forest called The Illusion of Preservation, that some of you may be familiar with. And at the time in 2001, the thesis of that paper really was focusing in on how much local conservation was happening in Massachusetts, conserving land, that there was also a tremendous amount of wood use happening in the state, but very little of that was coming locally. So there's an export of that demand elsewhere. So you're protecting locally, but still consuming and exporting your impacts out there. And so today what we're seeing in many cases is this illusion of proforestation, where there's a real push for kind of carbon preservation in your backyard or carbon preservation in your state. But we're still consuming wood at these tremendously high rates, which means that as we take more and more land out of that land base that actually supplies our local wood, we're pushing more and more of that demand outward. And so if we look at the 6 New England states, based on the 2019 wood consumption and removals, Maine's the only state that's actually kind of cutting more than it's using as a state. And New England as a region actually exports 45% of its consumption somewhere else. What's ironic, those that have kind of followed some of the push and movement to kind of preserve and allow forests to mature without any management in the name of carbon, much of that's come from states that right now are exporting 93% of their wood demands elsewhere. And so if we look regionally at New England, bearing in mind we have a latitudinal gradient, some shifts in composition that are affecting this. But if we look at kind of total above ground carbon, much of that stocking is in southern New England, parts of New England where there's actually a much lower rate of cutting. And so even looking at kind of the equity of where carbon storage is being distributed, where our wood consumption needs are being kind of absorbed, we need to be thinking about, is there a big trade-off with us doing local carbon preservation, but still consuming wood at the same rates as we did prior to that being our top objective. So I'm going to skip this because I want to have 15 minutes for questions, but I'll leave it in the PDF so people can see it. But this is just a summary of some of these trade-offs based on old growth restoration, but kind of what we're seeing out there, and end with just kind of how do we balance this? And as Smith said, and I think many of us know, we can't satisfy every single objective from forests in every single acre, right? And this is not a new challenge. And Smith in '62, and then those that follow the history of the triad that came out in 1992, largely motivated by trying to balance, biodiversity conservation with the fact that we are still consuming wood. And so how do we meet the needs of kind of both species that need reserves as well as us as a species that's using wood at a really high rate? And so those that are familiar with the triad, thankfully continues to have tremendous impact and application today. The idea with the triad was that we would divide the larger kind of forest estate into 3 general land uses. One being kind of what we can call these wildlands, ecological reserves, so areas where there's no management, which we need for various reasons, including biodiversity conservation and carbon. Other areas that are being focused more on the wood production needs, and then in the middle, areas that are being at the time called new forestry. Now we call that ecological and adaptive silviculture, where we're really trying to balance many objectives, managing based on natural disturbances, really using the body of science that's developed over time. And what's happened, unfortunately, is that these ideas have been out there for balance, and I think many of us kind of appreciate the importance for having this balance, but this push for local preservation for carbon, and then at the same time, that outsized reliance on wood from other places and oftentimes wood from plantations, either in the US or elsewhere, has kind of taken away this middle ground where we actually have the opportunity maybe to have the most impact on meeting a diversity of needs. And what it's done, and this was in a great book called Plantations and Protected Areas, it's done what we call this bifurcation of our land base, where either we have ecological preserves or we have areas that are producing our wood, but nothing in between. And what I think is really unfortunate about this is it's not necessarily within a given state or given ownership. Sometimes it's one country or one part of the country that's affluent enough to afford to get their wood from other parts of the country or other parts of the globe. And so this creates this dynamic where there's not only ecological, but also some tremendous equity issues associated with it. So what the triad, and really many argue for, and that I think we need to be thinking about, is we need these mosaics of diverse and ecologically complex conditions that factor in both these dynamics that would sustain resilient ecosystems, but also factor in that what's great for one species is not great for another. Likewise, what's great for one worldview is not great for another. And so having those mosaics of conditions that both are emphasizing carbon, we want carbon to be a key objective, but is also factoring it in with other things that we care about. And also understanding that certain conditions can provide a whole range of benefits for a whole range of species. And so this graph here is just showing both the core territory back there for blue-winged warblers, and then actually their overall home range in an area in Pennsylvania. And you can see where that blue-winged warbler has been hanging out. Those familiar with that species often associate with as an early successional species, but it's clearly also benefiting from adjacent mature forest as well as mature trees interspersed within that. And so even this fine scale mosaic for an early successional species is providing a wide range of benefits that wouldn't be provided if this was just wall to wall early successional. So having that mosaic at fine scales, broad scales is really important. And I think the challenge is that we almost need to kind of return to the time when we were talking about balancing multiple objectives, moving beyond multiple use, thinking about ecosystem management, and really speaking to the value of having this mosaic for supporting a whole range of wildlife carbon and adaptation objectives, as well as those cultural values. Because I think right now we're getting into a conversation where it's kind of carbon or bust. And in many cases, it's a challenging narrative to argue for. I'm going to cut that patch of woods because it's important for this warbler. When you look at the carbon data, it's hard to argue against that. And so more holistically looking at this question. So I'll finish just by saying, I know I was maybe a bit negative on the trade-offs piece, saying you can't have it all, but I would hopefully remind you that there are a lot of co-benefits that exist between forest carbon management and adaptation. The key is that we're using the stewardship models that we've been gaining such experience with over the last several decades, really understanding both how do we balance across landscapes, but even at the stand scale, how do we use understanding of natural development models and ecological silviculture to really do things like create complex young forest and create old forest that has complex conditions that can be resilient to climate change. And so using that multi-objective lens that really factors in both diverse ecological perspectives, but also diverse worldviews. And I'll end with just, I think, the most unfortunate part of how this is rolling out, because it's state by state or national forest by national forest or region by region, is that we really are taking a global issue and localizing it in terms of the solution. And there's a real challenge right now, and that there's certain areas that there's this effort to maximize carbon storage in your backyard, which is kind of a counterbalance to not in my backyard, right? So it's basically, we don't want cutting, we want carbon either in our backyard or in our state. But the challenge is that we're not seeing concurrent call for people to stop using as much wood as they did prior to making that proclamation. And so we need to be acknowledging that, number one, wood consumption should be reduced, but number two, that we still use wood. It's an incredible renewable resource. And so we want to be using a combination of passive and adaptive strategies that allow us to both produce local wood, produce habitats that are needed, produce cultural values that really are factoring in both these ecological outcomes, but also what are the equity and environmental justice implications of us kind of locking up one area, but still getting resources from elsewhere. So I'll end by acknowledging again, Caitlin Littlefield, also John Bradford really was influential in thinking about trade-offs, a decade ago, and Paul Catanzaro has been great with all the forest carbon work and many others. And certainly I'm happy to take questions for a bit here.
Thanks so much, Tony. Great presentation. So with our remaining time, we're gonna move to the Q&A portion of the webinar. So I've been monitoring the chat feature, and we'll start some of the questions we already have. Please remember to submit your questions in the chat box moving forward, though. So the first question, I'm going to combine two different questions I saw. The first is from Jenny Hellman, and she asks if you've seen any groups that are willing to finance this more long-term approach to forest management versus, say, financing for short-term maximization of carbon. And likewise, Mary Rodley asks if there's a way to incentivize forest management that doesn't optimize purely for carbon.
Yeah, I think the challenge, and I know I kind of really emphasize some of the regulatory frameworks and the carbon baselines for those. So that's, you're kind of getting into it with an assumed baseline and then assumed future. And so in some cases, a lot of these programs, and I'd say like the Family Forest Carbon Program, even like the practices that landowners are getting payment for there are elements of those that certainly do contribute to ecological resilience and can contribute to diversity of conditions in the landscape. And so I'd say some of those programs have been good at acknowledging that there's going to be some management needed to achieve these goals. And I think also the landscapes those are first being tested in have invasives and high deer browse and all these challenges that kind of create issues. And so some of the practices in that menu, as well as the practices within the Northern Institute of Applied Climate Sciences adaptation menu for carbon, take a more holistic view at that. But I would say that a lot of the straw dog I was talking to is more of the broader public perception of this, that any management is counter to carbon. And I think that is based on that immediacy of a cut and what that means for carbon, as opposed to the kind of long-term stability of those stocks. And again, thinking also with some of the practices within that from the forest carbon program, even though it's a short time frame that folks are getting into, many of those do provide some opportunities for diversifying. So there certainly are some programs, but I think the issue is, and I'm not belittling it, the climate crisis is tremendous. And so I get the general public saying, why would I reduce the carbon stocks in that forest? Shouldn't we be keeping it all out there? And who really is worried about that moth, but I think, we want to make sure that we're honoring all of our obligations to the forest, not just the carbon one.
Great, thank you. So Denise Chang Yen asks, does thinning potentially result in high carbon stocks over time, irrespective of wildfire and infestation issues? Just wondering if thinning may provide room for larger trees and more structural complexity over time.
So thinning can come close to unmanaged, but this is the function of growing stock relationships. Once you thin that forest, it never fully occupies that site like it did again. The one to your point, the one thing, and you might have seen that in that graph, the real low density stand, when I showed large tree density versus carbon in the red pine, they stopped actually thinning that forest after the first treatment because it was such a low stock, and they're like, we can't really keep thinning this. And so it was a combination of the trees getting big, but also there was a bunch of ingrowth, so it kind of became a 2H stand that the carbon stocks got greater. But if you just look at an even age stand and that cohort over time, it's really hard to ever reclaim that space, even with fewer and bigger trees. And so some of the studies that have looked at that, the thinned forests get close, but they're often still, not as high in terms of the live tree stocking. But as I pointed out, high density stand conditions, if you want those trees to live long and kind of have the architecture to last, we think about like old plantations or other just dense scenarios that resulted from land use, that really those trees are going to compete, have really small crowns, really poor kind of stem architectures. And so even though that might give you high carbon stocking for a while, those trees are not going to live 400 years, whereas a stand that's thinned, we're actually able to enhance that tree level stability, et cetera, will be better. But the long-winded way of saying it's actually, you can get close, but it's often that thin stand, the unthinned stand still often has a higher carbon, just because you reduce that growing space a little bit. That'll be fine.
Great. So next question from Bruce Kernan. Is there a role for fire in managing northern hardwood forests for long-term carbon sequestration and biodiversity?
Yeah, it's tough. I think in parts of those ecosystems, obviously northern hardwood forests, there are some community types that definitely are drier mesic community. So they still might have some of the signature species, but can also trend towards having more red oak, white pine species that historically might have recruited in onto those stands where fire was escaping from other parts of the landscape. And so there's certainly some role in those ecosystems, and I guess I talk about northern hardwoods, I think about what it feels like I live in the Pacific Northeast right now, with the level of rain. In those forests, there certainly could be fire, but it'd be challenging, at least in the current climate pattern, and also what's the projected climate pattern for prescribed fire in those ecosystems. But there certainly are species that are projected to start doing better in those ecosystems, like oak, like hickory, that are adapted to those regimes. And so thinking of ways that we could creatively kind of introduce those, using fire as a tool to reduce beach competition, et cetera. So, but in my mind, I still, even just based on the climate projections, view that as still a pretty wet mesic system, that it'd be hard to reliably use fire as a tool. But certainly in the region that those exist, oak systems and pine barrens and others, it would be a very logical tool to try to embrace more use of.
Great. So this is a bit of a longer question and maybe our last. Let's go for it. So Jennifer Shakun asks, I noticed in the map of relative density, some areas of northern Maine appear to have high relative density and would be experiencing self-thinning mortality. In other maps, I've seen these same areas appear as having low carbon stocking per acre compared to other parts of the Northeast region. Any thoughts on what's going on there, or how relative density is showing us something different than a standard measure like metric tons of CO2 per acre?
Yeah, and that's why relative density. So part of the thesis of the paper that was comparing like the CARB baselines to relative density is that CARB is using an absolute density, whereas relative density actually factors in kind of the developmental stage that forest is in. And so what's going on in northern Maine is that even though those are, some of those are, balsam fir forests that are 30 years old, that might not have high carbon stocking. They're still, in terms of the ecology of those forests and the level of trees per acre that are out there, are reaching kind of a self-thinning threshold, just based on the size and the density of trees that are out there. So relative density really factors those things in, as opposed to like an absolute measure of density that, if I say it's got 90 square feet of basal area, that's like, could be a good amount for a northern hardwood forest. That's nothing for a Douglas fir forest, and likewise, it's got 150 megagrams of carbon per acre. What is that, relative to what the maximum potential is? And so relative density really can factor in those more biologically meaningful measures of site occupancy that can then help you understand like how vulnerable is that stand to mortality and loss of carbon to that pool.
Great. Okay, so we have 1 minute left. I can't resist going over, if that's okay with you, Tony. There's a great question from Matthew Hunter. The science of sustainable forestry and silviculture are clear. What can academics and people in the industry do to change the message around naysayers? How can we best educate the naysayers about the scientific benefits of forestry?
I'm super proud of what I do, and so proud to be a member of SAF and the Guild, and proud to be in forestry program. But I also recognize that we have a reputation just broadly that's not always trusted, and I'd say like some of the argument, Bob Seymour really pointed it out, like why we went from the triad to the biad, which is just like protection and plantations, is that we're trusted to kind of grow pines and limes or Douglas fir. We can kind of do that, but like saying that I'm going to go into this natural forest and make it better. I think at this point it's harder to have that social. We've lost that social license, and for various reasons, and it's unfortunate because I would say I think it's just awesome both from an identity perspective, but also what we're trying to do with forestry, just how diverse the field is, and just it's a great set of tools to deal with some grand challenges. And so part of, I think, the solution is that we need to be really, hopefully, having trusted allies speak on our behalf. And what I mean by trusted allies is that trusted by non-foresters. So when TNC or Audubon or some parks district or somebody else is speaking, like it's so helpful to work with that forester, or we really needed forestry for this, like foresters for the birds is an example, et cetera, that it's coming from someone that's viewed as not biased. Like, I don't get a dime for a tree being cut, but because I'm forestry, I'm sure some think that I must just want to fill up log trucks and that's all I want to do. But so I think, finding those allies that can speak on our behalf, but also I think, we all need to find, and respect other worldviews and where people are coming from. And I think bringing in those worldviews and understanding, why what we do might not be received well from all corners can also be helpful, as much as it's sometimes painful. But I think just getting more people to get the word out that forestry is great beyond us. People, we can say till we're blue in their face, but I'd say that's not going to solve our some of the identity problem we have. And so I think we need more and more folks saying, gosh, that fuels reduction across that landscape like saved our community, or it really did amazing things for the woodpecker community, or did amazing things for this culturally significant plant that wasn't there before that we now can gather. So I think we just need to acknowledge to some degree just we have a past that's can easily get looked up, and when it's complicated. The cut stump is a complicated thing, and so we need to find others to say, hey, you know, the beauty of that cut stump is this value, that value, and really keep working at that.
Great way to wrap it up. So we're just about at time. We're going to close out the session today. I'd like to thank our speaker, Tony D'Amato, once again for his time and this great discussion. It was a pleasure to hear from you. The webinar recording and the slides will be posted in a few days. And you should know that to be included on our mailing list and to receive registration details and information regarding upcoming webinars, just email forestry@msu.edu. And before you head off, please take a look at the speaker lineup, which is shared on the screen right now. And with that, I hope you all have a great afternoon. Thank you, Tony.
Yeah, thanks, everybody.